Hello everyone. Imagine if you could eat delicious pastries, treats, pizzas, and all kinds of carbohydrates without gaining a single gram of weight. Is this possible? Of course, carbohydrates would need to transform so that they can't be digested by our enzymes. And this is possible by altering their chemical structure as they travel along the fourth orthogonal axis that defines the fourth dimension.
But this momentary visit to 4D space has another effect: it makes 3D objects that enter it disappear, as observed in some flying vessels. To understand this, we first need to comprehend the space we live in, which is defined by dimensions. The location of any object in our world is defined by three coordinates, x, y, z. In the animation, you can see how the three Cartesian axes, x, y, z, define 3D space. Notice how each axis intersects the others at a right angle of 90 degrees. In other words, each axis is orthogonal to any other axis. And this is very clear in 3D space. However, to represent a 4D space, we need another axis, the w-axis. But this fourth axis, w, must intersect the other three orthogonally. Is this possible? No matter how the w-axis is positioned, it will never find an orthogonal position to the other three within 3D space. This cannot be. But in geometry, it's perfectly possible to define a space with 4 dimensions, in which the fourth axis w is orthogonal to the other three. Therefore, in 4D space, the axes that form it, x, y, z, w, are orthogonal to each other, meaning they form a right angle. Our brain, which evolved in a 3D world, can't even imagine 4D space, but mathematically it functions perfectly well. It has its own trajectories and shapes, and it doesn't care about human opinions to exist. In our conjecture, the fourth dimension is present, and yet, we cannot see it. A one-dimensional space is perfectly described by a straight line. In this one-dimensional world, an entity can only move forward or backward. Left or right movement is impossible, as is moving up or down. Those directions don't exist. Forward and backward movement is the only possibility. Traveling by train perfectly illustrates this idea. At the front, you see the tracks passing by, but the configuration of that reality doesn't allow you to go left or right, or up or down. Sure, you can go backward, then forward, or backward again. Those are all the possible paths. A two-dimensional space is perfectly described by an area, a plane. In this two-dimensional world, an entity can move forward or backward, as well as left and right. However, moving up or down is impossible because those directions don't exist. You can only move forward, backward, left and right. Traveling in a car perfectly illustrates this idea. At the front, you see the grid of the plane passing by. But the configuration of that reality doesn't allow you to go up or down. Again, you can go backward, forward, left, and right. Those are all the possible paths. Our three-dimensional space is perfectly described by volume, a 3D space. In this three-dimensional world, an entity can move forward or backward, left and right, and even up and down, in all the directions we know. However, moving hyper-upward, meaning along the w-axis of the fourth dimension, is impossible in this dimension. This is because that direction cannot be seen in our plane. Traveling in an airplane perfectly illustrates this idea. At the front, you see the volumes grid passing by, but the configuration of our reality doesn't allow you to move hyper-upward, along the fourth orthogonal axis, the W-axis. Again, we can move along the X, Y, Z axis, but never along the W-axis. Flipping. Flipping in the third dimension. This consequence of the conjecture about fourth-dimensional objects is quite interesting. Because if an object of dimension n somehow moves and enters a higher dimension, n+1, it can undergo a rotation there and become its mirror image. In a 2D mirror image object, it's enantiomer. In a 2D world, we have the image of a right-hand glove. It moves, and it rotates, but it can't rotate to become a left-hand glove. No matter how it moves in its plane, it can't become a left glove. It's impossible. But for some reason, a 3D entity takes the right-hand glove and moves it upward toward the Z-axis. For an observer living in the 2D plane, the right-hand glove disappears. Then the glove rotates in 3D space until it becomes a left-hand glove. Afterward, the 3D entity returns the glove to its mirror image mode in the 2D plane. Then the 2D being sees the glove suddenly appear. But with astonishment, they notice that it has transformed into a left-hand glove. In other words, its mirror image. But while the glove is in 3D space, the 2D being sees nothing. Result of flipping, the right-hand glove transforms into a left-hand glove. Flipping. Flipping in the fourth dimension. If an object of the third dimension, for some reason, moves and enters the fourth dimension, and undergoes a rotation there, it can become its mirror image. In a 3D mirror image object, it's enantiomer. Now, let's consider a right-hand glove in the 3D world. It moves and rotates in space, but no matter how hard it tries, it can't become a left-hand glove. No matter how it moves in 3D space, it won't become a left glove. That won't happen. But for some reason, a 4D entity takes the right-hand glove and moves it hyper-upward. In the animation, the hand of the supposed entity isn't visible, simply because it doesn't intersect our plane. The right-hand glove undergoes a translation along the W-axis. For an observer living in the 3D plane, the right-hand glove has disappeared. Moments later, the glove rotates in 4D space until it becomes a left-hand glove. Then, the 4D entity returns the glove but with its mirror image structure to its original 3D plane. The 3D being then sees the glove suddenly appear. But to their astonishment, it has transformed into a left-hand glove. In other words, its mirror image. But while the glove is in 4D space, the 3D being sees nothing. Result of flipping, the right-hand glove transforms into a left-hand glove. Now we know why objects disappear from our sight. It's because they follow the trajectory of the fourth orthogonal axis, the W-axis of four-dimensional space. But what does this have to do with food? Any food that enters 4D space, after a translation that makes it vanish from our space, can undergo a rotation in the hyper-upward direction. In this way, the food reappears in its mirror image, that is, its image reflection. Carbohydrates are the most important energy source for all organisms. Which foods contain carbohydrates? Bread, pasta, cookies, cereals, rice, apples, potatoes, bananas, and so on. They are present in almost everything we eat. These foods are made up of molecules. Let's focus on the molecule present in almost all of them, glucose. The glucose molecule, like many others, can have a mirror image. Our hand is an example of a structure that can exist in both left and right forms. They are mirror images of each other. The same happens with the two forms of glucose. They seem identical but differ only because they are mirror images. This means we have right glucose, D-glucose, and its mirror image, left glucose, L-glucose. Each of these forms is called an enantiomer. The important thing to know is that our body cannot metabolize L-glucose. If we were to eat food made with levorotatory carbohydrates, that is, left-oriented carbohydrates like L-glucose, our body would be unable to metabolize them. It would be as if we were eating nothing, like eating paper. However, it would still taste like real food. We would obtain L-glucose by performing a flipping in 4D, which means rotating D-glucose in four-dimensional space. The result would be indigestible food that wouldn't make us gain weight. The same principle applies to proteins. They are primarily made of levorotatory amino acids, that is, left-oriented amino acids, like L-tryptophan. If meat were to undergo a flipping in 4D, its amino acids would become right-oriented, and we wouldn't be able to digest that meat. It would taste just as delicious, look the same, but it wouldn't nourish us. The result, we wouldn't gain weight.
In conclusion, objects disappear because they follow the path of the fourth orthogonal axis, the W-axis. Compounds transform into their mirror images because they undergo a rotation transformation in the fourth dimension, a flipping in 4D. That's all. Thank you for your attention.